All right, class, so we are about to do the last formal lesson for this week, the third week of distance learning. Update your table of contents, please. You should have valid claims, page 53. Making inferences from random samples, which was the last video you watched, page 54. Today is comparing distributions, page 55. So our learning goal, our standard is 7 SP 2.3 and 7 SP 2.4. This is page 55, comparing distributions. Now, the formal learning goal that we're doing, guys, is 7-9. We're not going to go through all these, even though we actually are covering every single level 3 learning goal in this video today. But the main thing I want to focus on is it says drawing informal comparative inferences about two populations. So we're comparing distributions. We're comparing two different populations, okay? To compare things, you have to have more than one. You can't just compare, I can't just say, hey, compare Hector to, you gotta have two things. Compare Hector to what? Damien, okay? Like you have to have two things if you're gonna be comparing or more, two or more. So we're comparing two populations, but the main thing I want to draw attention to is this word informal. So yes, for a lot of these problems, you can actually do calculations, but it's informal inferences. So a lot of it you can kind of just eyeball, and the only reason to do a calculation is if you want to check it or confirm it. So we're going to do 2 box plots, 2 dot plots, and 1 histogram problem. So 5 problems. So bear with me. This is the, in my opinion, most difficult stuff we've done this week. So if you need to break this up, pause it, chunk it into 2 videos, go for it. So we have a box plot, and it shows the distances in meters achieved in the final round by the top 11 women's discus throwers at the 2012 Olympic Games. So basically, we got the Olympics, okay, 2012. And we have the top 11 women's discus throwers at the 2012 Olympic Games and the top 12 women's discus throwers at the U.S. qualifying meet. Honestly, this stuff's cool with all this background, but all the important information is given in the box plot. So we have our U.S. qualifiers, and then we have the Olympic finals, and we have box plots. Now, just a review for y'all. Box and whisker plots. I know these don't look exactly like the ones over there because they're skewed a little bit. Well, this one's not skewed, but this one is. But this is 25% of our data. This is 25% of our data. This is 25% of our data. I'm just doing it above and below to make more, so I have enough room. So basically, 25%, 25%, 25%, 25%. Okay? 25, 25, 25, 25. We know 4 25s or 4 quarters makes $1, makes 100%. All right? This right here, that is our median. Or quartile 2. It's the halfway point. So 50%, half of the data is below the median, and half of the data, 50%, is above the median. All right? This is quartile 1. It's 1/4, 1/4 in. And this right here is quartile 3. It's 3/4 in. 25, 50, 75, 3/4 in. All right? The whiskers, the tails at the sides, this is the lowest point right here. This is the minimum value, whatever this is. That's the minimum, the lowest point in the data set. And here is the maximum. So that's a review, but you guys did do reading box plots last week. So this is just a refresher for this week. You guys also did box plots in 6th grade. So I'm sure you guys are aware of this. You just need to be reminded of it. So let's read the answer choices. The distances in the Olympic final were farther on average. So the Olympic final, it's saying the distances were farther. So let's look. Distances in meters, 50, 55, 60, 65, 70. Well, this box plot is definitely farther to the right. So it's farther distances. Which one is this? This is Olympic final. So I think that's a yes. Oh, it says choose all answers that apply. Okay. I wonder how many of you guys select one and then just say confirm or check. And then it's like, you're like, oh, I didn't choose all the answers. So the Olympic finals on average have farther distances. This box, actually the whole thing for the most part is farther to the right, farther distances compared to the US qualifier, which is just this that overlaps. So these are all farther to the right, farther distances. All right, B. The distances in the Olympic final were all greater than the US qualifier distances. So for this to be true, that means there's no overlap in the box plots. Is there any overlap distances between the purple and the blue? Yes, they overlap from right here to here. They are overlapping. So that means these distances for the US qualifier ladies were the same distances as the Olympics. So no, they're not all greater in the Olympic finals. They're on average greater, but all greater is way too specific. It's way too black and white, so no. We can eliminate D. This is none of the above. Okay, C. The distances in the Olympic finals distances varied noticeably more. So varied, guys, varied. How varied it is, the word varied means how spread out it is, the spread or the range. So varied means the spread or the range. So how wide is it? Which one varies more? Which one has a wider spread? Well, US qualifier goes from, that's 54, because the ticks are going by 1, to, what is this? 60, 61, 62, 63. So the US qualifier goes from 54 to 63. How many is that? 55, 56, 57, 58, 59, 60, 61, 62, 63. That's 9. So the US qualifier has a spread or a range of 9. Because 63 minus 54 is 9. Okay, let's see the Olympic final. The Olympic final has a spread or a range from 60 to whatever this is. 1 less than 70, 69. So the Olympics, oh, I put a Q, okay. Olympics has a range or a spread of 69 minus 60, which is 9. Both have the same range. So they've spread out, they vary the same. So one is not noticeably more, no. So the only answer is A. The distances on Olympic finals were farther on average. Okay, the next one, I would recommend pausing it and trying it on your own. Get practice on it. Then if you don't understand it, you know, okay, I need to practice this more. I need to watch a video. I need to look at Miss Fry's last problem. I need to contact Miss Fry, ask questions. So we have our box plots that show the height in centimeters of the players of the University of Maryland women's basketball and field hockey teams. So we have the basketball team in purple. We have the field hockey team in blue. And this is their height in centimeters. So we know the bigger number your height is, the taller you are. Someone who's 6'8" is taller than someone who's 4 foot tall. Which pieces of information can be gathered? Choose all that apply. A, the basketball players are taller on average. Well, the higher heights are to the right, and the basketball is definitely farther to the right, because we know this box has 50%. It has half of the data in that box. And that is completely higher than their 50%. Plus, we have all this 25%. So we have a lot, they're a lot farther to the right, to the higher heights. So yes, the basketball players are taller because they're above the higher heights. So yes. So as soon as we know there's an answer choice, we can get rid of none of the above. B, the heights of the basketball players vary noticeably more. Varied. Remember, vary equals spread or range. Varies how spread out it is, the spread. It's the range. So when they talk about average, we're talking about the center. We're talking about the box. We're talking about the median. So the median was higher. It was a higher height. This whole box was higher. So we're talking about the center. When they talk about vary, we're talking about the spread. Okay. So right off the bat, without even doing the calculation, the basketball player is all the way from here to here. That's pretty dang wide. That's a wide spread. It's all of this for the spread for basketball. Let's see what the spread is for hockey. The hockey is much smaller. Much smaller. Small for hockey, much bigger. You could actually calculate the range, but there's no need to because it's obvious that, man, these arms, the whiskers, are much wider for basketball than for hockey. So yes, that is also true. So those are box plot examples. Okay, now we're going to go on to dot plots. We're still on the same page. Okay. At the Olympic Games, many events have several rounds of competition. One of these events is the men's 100-meter backstroke, so it's swimming. The dot plot shows the times in seconds of the top 8 finishers in the semifinal round at the 2012 Olympics. The lower dot plot shows the times of the same 8 swimmers in the final round. Okay, so we have the final round for swimmers and we have the semifinal round for the swimmers. It's the same 8 swimmers, it said. Which pieces of information can be gathered from these dot plots? So important. Remember that the lower swim times are faster. Usually when you guys hear like who's better, who's faster, we look for the bigger numbers. But think about it. Who's faster? Miss Fry, that can solve a math problem in 10 seconds? Or Gabby, who can solve a math problem in 90 seconds? Who's faster? Miss Fry. 10 seconds is much faster than 90 seconds. Okay, but 10 is smaller than 90, so you have to remember that. Faster is right here. This is faster for times. Faster is smaller numbers. A 6-minute mile is faster than an 8-minute mile. So I'm going to write those notes there just as a reminder for me. For times, faster is smaller numbers. A, the times in the semifinals were faster on average than the times in the final. So it's saying semifinals faster than finals. Well, faster times are lower. And we see that the final rounds, we have, well, let's just look, because we see a lot of dots right here. So at this time, we have 1, 2, 3, 4, 5 of the 8 swimmers. 5 of these 8 swimmers, oops, I didn't mean to circle that one. 5 of the 8 swimmers got faster than 53.123. Whereas only 2 of the swimmers in the semifinal were faster. So we have faster times at lower numbers for the final. So times in the semifinals were faster? No, times in the final were faster, so no. B, the times in the finals vary less than the semifinals. Varying, how spread out it is. Well, the finals is spread out all this much. That's pretty spread out. The semifinals are spread out much less. The spread of the final is like my pinky length. The spread of the semifinal is like half of my pinky, maybe a little bit bigger. So the finals is much more spread. The time in the finals vary or spread less. No, the finals vary more. More. The finals vary more. Finals vary more. They have a bigger spread. So it's none of the above.